Okay, I'm recording. Before we get started, did anybody have any questions on assignment 3 that they needed to ask? I think that's due tomorrow night. So. I guess on that note, the makefile for assignment 3, I had to update it. I was using an outdated version when I uploaded it to Canvas. So make sure you re-download the makefile, specifically, if you haven't already. I made an announcement about it in the Discord. But yeah, definitely download that if you haven't already and you're having issues with compiling. I don't see any questions on assignment 3, but feel free to stop me at any point. I think that's about it for administrative stuff, so let's get into this. What I wanted to do today, because I think we're a little bit ahead of schedule, is spend a little bit more time reviewing some of the concepts that we've gone over and doing maybe a practical example on top of the one that we did last class, which we also introduced virtual and abstract functions. But I did want to finish that example first. There was one mistake that was keeping it from working last time. So if you remember, like the player just wasn't appearing on screen. So we had like this game, essentially, right, that we handled controls and like updated every frame and did all this stuff. And we had inherited classes from a game object class, which just represented everything inside of our game. And then we had a player and an enemy, which inherited from those game objects, and then we're able to override the virtual function called update, which determined how something updates itself on a single frame of our game. And the player just wasn't showing up, which was evidence that the virtual function was working, but I realized I had something in my lecture notes that I just hadn't finished writing yet, and that was the only thing that needed added to this, and it's on Canvas with the fix, and it's this line right here, I think. This is the player class, and then this is its update function, which is virtual. So it was overriding the game object virtual update function. And the reason this wasn't working is because the game object version of that function did some stuff, and specifically it adds the object to the screen so that it gets drawn every single frame. That affects its actual ability to be drawn. Not so much where it is on the screen, but the fact that it's showing up. And so that was my error, and then there was just a print statement that we had there. But yeah, this was not getting called, and I wanted to talk about this a little bit. We said that the way virtual functions work is that they end up overriding behavior from a base class and then redefining it in some way, or give you the ability to redefine it in some way. And so when I make this virtual in this update in our game object class, and then I do it down here in our player class, I'm saying that the player is going to update in a different way than its base class does. And this is nice, again, because it allows us to say that they all have this function. They can all share the same function that they can call, at least, but we can redefine the behavior and then make it do something different based off the classes. And we're going to expand upon that later with the example I have in mind. But the thing to note about that is, what if I actually want the behavior that was associated with my base class on top of any new behavior that I want to add to this? Now, one solution would be I just go up and copy and paste this. Right? I could just copy and paste all the code that was in the game object update function, and that'd be fine, and it would work down here. That's okay. Although that almost defeats the purpose of doing this object-oriented programming, because we want to encourage reusability of code. That's not a great solution. But what we can do is actually just call that version of the function. So let me scroll back down. In this update function, I can call the game object version that I overrode, and so even though I redefine the behavior, I can still go back and look at it if I feel like I still need that function to be called. And so that's what this line does. The way you do this is you just specify the class name, you give the scope resolution operator the : the way we've been doing with a lot of things if you need to resolve some ambiguity about where a thing belongs, like what class it belongs to, then this is the way to do it. The same thing with namespaces, right? So this is just saying call the game object version of the update function, and it will just do that on top of our actual code. This code here is going to apply gravity to only the player, and then call the normal update function that all game objects have. So if we run this really quick just to make sure that it actually works, we should see that the game, while it's still kind of janky, does kind of work. And you can see the little updating flashes there for a second if the frame rate shows it. But if I hit like right, you'll see that the player moves right and the player moves left, and then the difference between the player and the enemy is the fact that the player can jump, and then afterwards they fall back down to the ground and have gravity applied to them, because that's what we changed about the update function for the player as opposed to any other generic type of game object. So as it stands, the enemy is not redefining the game object virtual function, I believe, in our code, and so it's still just using the default game object update code, whereas the player is using this new one that we've written and then referring back to that game object update code afterwards. Just wanted to clarify that. It was something I meant to cover. I had it down in my notes and then I forgot to mention it. And then I think there are two more things I wanted to address with this. One of them actually pertains to just rewriting part of this. Let's close that out. I wanted to go over dynamic allocation of multiple dimension arrays. I think last week we discussed a little bit single D arrays, like 1D arrays, and doing dynamic allocation with those. And I wanted to do an example of doing 2D dynamic allocation, because it's going to definitely pop up in an assignment later. And I think it can be kind of tricky to wrap your head around at first, because it's not the way that I think you would think an array works. It's a little bit different when we do it dynamically. I'm going to comment this out, and what we're going to do is we're going to redo this to use a pointer. I'm going to comment this out when I upload it to Canvas, but it's going to be here just as a reference if you need it. And you shouldn't do it for something like this. If you ever think the size of your 2D array is going to just stay the same over the whole runtime of your program, don't do this. It's just like both bad for efficiency and like way harder to code. So don't do what I'm going to do normally, but we're just gonna make a comment here. So example of a 2D array allocated dynamically. And before we actually get to the code here, let's go ahead and just try to visualize it a little bit and get an idea of what it is that we're doing. Now, the normal way that you would do an array, or how you might envision it, sorry, I need to change my pen settings. There we go. If I was to do the array the way that we had in the code previously, in the way that you're taught in 135, is to just do it like this, where you give the name of the variable for the array that you want. I think we called it screen, and then you just give a size for each dimension. So I think it was something like screen Y, then screen X, hopefully. And I'll explain why that's backwards in a second. It's like Y and then X and not X and then Y. And then this would, assuming that screen X is, let's just say, some sort of constant like, I don't know, 16, and screen Y is 9 or something like that. And what this does is it goes and allocates a 2D array that's kind of like a table like this, right? Where there are 16 of these columns. I should probably draw everything first. we have like a Y and then an X. And the reason I'm doing these in the backwards order was we generally go row first, then column. And so I would index these ones. This would be the Y direction, traditionally, right, is up and down. And you do column first and then row afterwards. So dot, dot, dot. And then this would be 9 at the very end. And then this one would be the X. So 0, 1, 2, dot, 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 16. And then you could go and access any individual game object that's in there, right? So each one of these cells in our array represents a game object, which may or may not be there, depending on if we've set it, but we can go look it up, and that's what a multi-dimensional array does, right? It just allows you to store things based off of different dimensions. And then the reason I do this Y and then X is so that it's just, we're drawing it to the screen, so we actually have to consider like some math positions and like coordinates and stuff. And so I think that just helps a little bit. But right, this is how our arrays work. Yeah, we access row first and then column. But we think of them all as like aggregate. Or my mic setting's a bit off. Let me try. How so? Do they sound quiet or like distorted or? It's really choppy? Oh. Thank you for letting me know. Let me check. Noise removal. The only thing I changed was this, I think. Does it sound any better now? Okay, fair enough. Let me know. I'll keep going a little bit. If it sounds choppy still, just stop me. And thank you guys for letting me know. Before we get too far. Okay. I guess... Let's see, where were we? This 2D array was like just grouped together. It looks like a table, I guess is the point I was trying to make. You know, it's just like how you would normally think a table would look like, or like a matrix or something. But we actually have to do it a little bit differently when we do dynamic allocation. So this is our static allocation, meaning that it's done just one time and you can't change it. The array just looks like this and it's fixed. So a dynamic allocation, which we discussed a little bit last week, this is for examples where you maybe want to change the size of your array over the course of your program, or you might not know the size that it needs to be until it actually runs, and so you need to use some sort of variable to be able to tell how wide it is and how tall it is, or how many ever dimensions you have. You might need to specify that in some different way that's variable and not something you know immediately. And the way we were doing arrays originally with that, so let's just say I did a one-dimensional integer array, is that we use pointers that point to a strip of memory space, and that's where our array is. And so if I had this, then this line would keep a pointer to where this array is allocated in memory, and we give it the new keyword, right, and then the type of the thing that we want to allocate, and then the braces tell how many things to allocate. For instance, if I did this, then this would go somewhere into memory and make 5 integer cells. 1, 2, 3, 4, 5. That we could just index like normal, right? So after we've done the dynamic allocation, we can use the array exactly how we're used to. Nothing different about that. But this is just kept as a pointer. We have some sort of pointer that points to the beginning of the array, and then we can access it like normal. But the one constraint that we have on these is that they're in single strips of space. And so we actually have to still deal with that when we're doing multi-dimensional arrays, which kind of poses a problem and is a little bit tricky at first. So first things first, don't ever do this. So if I wanted to do a 2D array, we'll call it R2. This should not work. Just giving two things like that is not actually going to work. That's not going to allocate a 2D array. And I see some people get stuck because they'll try that at first, and it's not going to work. I think it will give you a syntax error. So this is not actually what you're looking for, although I think this does feel more common sense, so I totally understand why people do it. Instead, we're going to have to do this as a bit of a weird way. With that screen example that we had earlier, since I can only allocate one-dimensional strips of memory, what I'm going to need to do is then allocate each row individually. So if I wanted to, let's just say, have a 3x4 array, then we're going to kind of need to split it up so that each row is floating by itself, and then keep track of where those rows are. So you can think maybe normally these would just be all next to each other, and like all these rows would be joined, but now we just have each row of the same size all kind of packed together. And because of this way that we're doing it, we can actually have rows of variable size, so I could have like the first row be 3 and the rest be 4, which is a little weird, but we're just going to keep it like our normal arrays for now. And then because of this, I need to keep track of all these. So remember, the way that these 1D array works is that we have a pointer to them. So what we're going to need to do for these dynamic arrays, because all of our arrays are separate, they're just these dynamically allocated single strips of memory, is that each of them is going to have their own pointer. So this is going to be, for instance, the pointer 0, this one's going to be pointer 1, and this one's going to be pointer 2. And so you can imagine that now that we are going to be keeping multiple pointers to arrays, we're going to need another array to then be able to access those arrays. I should probably change this to blue, and I'm going to change it here in a second. So what I'm going to actually need to do is make an array, which is the height of my 2D array, and then have it point to each of the rows in my actual array. This would be index 0, index 1, and index 2, and they're each going to point to individual things here. This would be 0, 1, 2, and 3. So this is a 3x4 array. This statically would look something like this. Whoops, I'm sorry. I've been writing something. Forgot that. We were doing screen, right? It was a game object pointer. And so you'll see pointers, you'll have one for every dimension of your array that you have. Our first one is going to be a pointer to this, so I'm going to make this yellow. This is going to be the pointer to this array that then points to the rest of our arrays. You'll sometimes hear this be called indirection as well, where you just don't have a direct access to your memory that you want. Like, I can't just go straight here. I have to go to this array and then that array. So I kind of have to like follow all these arrows. But this array that we have here is going to... We're going to have a pointer to this master array that then points to all our other arrays. I'm going to call this screen. And this screen that I made is 4x3 here. And again, this one at the top is not actually the syntax for it. Oh, I'm sorry. 3x4, my bad. 3x4. So this blue dimension represents all the pointers to that thing. And you can imagine, like, every time we have a pointer, it's going to point to another thing, and we can kind of imagine removing it. So if these things are all game objects that are stored in this array, so this is like game object, that's a game object, that's a game object, this then is a pointer to a game object because it points to the array that it's in. Which makes sense because we said that 1D pointers, or pointers point to 1D arrays, and that's exactly what all these blue ones do. They point to 1D arrays, and then this yellow one here is pointing to those pointers, and thus is a game object pointer. This thing right here is a game object pointer. Because it points to an array of pointers that then point to game objects. So you can hopefully see why this can become confusing, but this is just generally how we're going to have to allocate this. And we're going to write the code in a second, but so far does this concept make sense of allocating rows and then having pointers to those instead? Any questions? Actually, is my mic sounding okay too? Still kind of choppy? Ah, still probably choppy. I can try leaving and rejoining. Let me do a quick test. Just see if it's my microphone or if it's WebEx. Because if it's my microphone, then I better fix it, because then the recording's going to be messed up too. Let me just test this with Audacity. Low volume too? Is that any louder? So let me just test this with. I think it may just be WebEx, because it seems to work on Audacity. A project before. I will be right back then. We'll see if it fixes it. Okay, does it sound any better now? Open chat. Is the audio or the volume any better at least? Oh, you know what? Let me check one thing. No, I think it's okay. Can anybody at least hear me okay? Now it's good? Now, okay. Maybe worse. How about now? Better? Well, it's not choppy. Sorry, I did last year. guess on that note, back to have I think of one thing mentioned kind of offhand, not going to be part of any. Also, kind of because not limit other and category. Even though these are boring, as we have points, don't necessarily have to be kind of stagger them on place and just put them wherever. Nice because talk to higher array allow you to put it in different. Kind of nice. Oh, right, I remember. I'm gonna actually try to pro. Actually, array of pointers. Imagine if higher dimension array, adding levels of wherever your final destination. Want to order that we one first allocated kind of need allocate it in the oh if we were for instance access here I think I start at pointer or pointer that a which is one I have to follow as we go a before one allocate that try to do allocate array of actual that with one single allocation always one is we will allocate object pointer goes I belongs to I call it array of pointer actual a row this is how many back and look we're going to need to allocate we're going to variable amount we'll just have one array meaning that we're going to need that means go through okay, so tree our array that take that row for the pointer needed I'm going to allocate there. Paste X long. Oh, that's just allocate each of the or pointer to kind of simulate how. Oh, as our clear right now. Also, I write a stat function. Actually, and when it makes a difference. Pointer. Also, why I was going to say also why when you argue we have a question. So you have a array name. Yes, they're technically on alt screen, and then I'm basing it with dynamic allocation of it. All of you this version now, that one still a 2A, it's allocated. A we're doing at runtime, and we can decide what size we want. A it doesn't have to be fixed based off of that. It up row allocated somewhere, and it's pointer because of that. You can say that indexing a work basis after it access that that one. It's kind of like a multi where to go. case of a last thing, I'll just a lot more. And yeah, I see. So every dynamic allocated going to have an array of pointers finally reach. I guess I was just saying this have a either now if we run it, try to fix it out regardless. At least how we would go allocating it. No, any final questions? One last thing, unrealized I should think assignment 3 was word makes a variable called x. The word const just makes it by it, and that's a const math actually fill it in or anything. It's just a variable. Make it so that it never be assigned to. You can't write it. It be the same thing in a function. Probably the get have a function constant plus plus. class E. I have a private function, call it at x. Actually, int at x. You can mark a actually put it after the name function rather than before it when you're function. All it means promise by anything. Either will okay x. Try to do side effects that changes a variable or something about program. There are certain scenarios where it requires you to do a const plus. It's not. Sometimes they'll just require you to do it as like not going to modify anything. I think the big one is if you declare a const function, all const that const. I try to do anything that one works like that is out any because C out is something fundamental changes something. That's writing to an output. Does right. That's considered a side effect. When you call this function, you have to rather than something that affects other parts of your this modifies buffer. What's text? That means it did something that not clear. That's that's that would be enough. That word may pop up much about it. It should, but can't modify anything in the function const after offhand. I'm going to do one more example. Abstract. Kind of mind and get a better idea. Try to I have in mind a program that just calculates area and are going to keep a base class shapes. try to draw it up just right what we see here. Another one finds, and then we want to be able to override this. I think we'll just find area, then I means this on top of that. Our example area of rectangle, kind of assume also the length times the width, all four. Thing we wanted to consider whenever any kind of class setup or work is have going the opposite actual class hierarchy. Circle is a there is a there's a rec. I try to go backwards. Let's try to set the the other thing I guess or sorry before we get they're all going to find area and different that we also abstract. What would it kind of here because what the is in order. I just ask you find the area. Just that and when something is not specific enough that let's make an abstract shape class and try to all right, does any I wanted to make yep the definition of that have to be that function. Not defining the code have to act public C plus inherit for the I am thinking then let's just rectangle eight probably right construct and let's we'll do rectangle that last hands of rectangle like this actually no I take that back one actually gonna write this for a constructor think about one way we could do this and could have written the formulas in the way I wrote earlier. You can realistically find any area or there's a rectangle lazy say that the wave, and then if we wanted to call the, I could divide it length for. How could I constructor? Yeah, colon last name. I want to call the rectangle constructor. Call it with just length. Then going to constructor also. Just as a reminder, you have to do it if you're intent. I'll call in the context of that a constructor creates a fact I could create a variable r that creates a local and it dies when the I made like x and this thing happens to that one not going constructor. Part of the reason it is just keep one I mean plus it also just have options in mind. I won't regardless files happen. We'll do some ways and f. Writing patience charge. Oh, that's because I had constructors. Um, one had of a circle or the circle I constructor just at the rate. Remember that we can do that with this keyword. Also called have an ambiguity. And then the area of this fifth last week. Simple code, but across the define the way we can redefine a find area class that's abstract. Tell program how that works here. Find how later. So I can also read a where if I've already written there, then I can go and question. Oh, sorry. Do you mean? Sorry, I was like a lot of stuff. No. This in refers to current well, it always refers to current object calling program. It in constructors pretty often if you remember I did something. This is from your stuff. There's a variable called x. Go and I declare x. What what right? Reason is whenever you use it looks at them and it kind of climbs up the most recent. Consider we have scope, scope, scope here. Then I have x. I have scope of the line that it's the this outside out x at x scope. If it doesn't find x, I out here that it or if that was gone. no more ambiguity. Now it knows when have started with overshadows. We defined that because of that, when classes have their own, any function inside of a class, I create a class called that. That also, and then I have this everything that's X. Look at the most. I just yep, right because most recent smallest it's looks at red one nested. Can't really have like this and that's that causes. I want to set the width base here. Want to set, but in the context of our constructor, both this only really have access to change our program, or the compiler can give this always reflect our program. And this one is like we one because it's just called try to resolve the name. That means looks using constructor parameter, not the. However, this key solves the tells you I want the at both. Think of it like how if I was to x x variable access that would be the red one. The reason we know it's the that it's one that belongs to people, which is x. So it means the way you access things generally with a dot, but you can also do basically on the point this here and are the same. And you can have a variable name. Once you actually go past you variable that know what the name is. All that that's what knows. In other words, it access all much like how if I did dot n. The other question that is it just a matter of coding style to use? Yes. My code. That's yeah. It's just a matter of I preferred I in mind even treated. That being said, it's important to know for certain cases you'd have to pass it, even though it's nice for solving it. I don't understand. I think you'll see another. Actually, one last note. If I that longer work, putting other this one again, which class that it belongs to is also the class that do this. Looks like that one. Let's take our head. Take a radius C. Should be about if it's pi r squared. Last thing, verify. Have the option. I can sorry, a circle. Right. I can store a circle object. Right. But C++ it has to be. I'll finish the point here. we wanted to shape. That's nice because if we have a bunch of different shapes and we can separate rectangle. Array can only that's that better. Okay, sorry to take extra time. Try to get that done.